Okay, this is the fourth and final transformation. So we started off with translations, we went to reflections, then the third one was rotations, and now the fourth one is dilations. So here we go. All right, so basically what you need to know is that you're going to start with xy, of course, for the rule, and then you're going to see that it's going to multiply x and y by the same number. And that's pretty much it. And then once you multiply and find your new coordinates, you just graph it and that's it. You will notice that when k, which is just the number, that you're multiplying by, we call that the scale factor. When k is greater than 1, you're going to have what we call an enlargement. It's going to get bigger. And then when k is less than 1, you're going to have a reduction. And then if k is equal to 1, nothing's going to happen. So there will be no change. And again, we call k the scale factor. So the scale factor is just the number you multiply by. All right, number 1, dilate the figure by a scale factor of 3 with the origin as the center of dilation. Okay, so all we're going to do is take all 3 of these points and multiply them by 3. Let me write that down as a rule, just so you can see what it looks like as the rule. So that would be 3 times x and 3 times y. That's literally what the rule looks like. So if you see a rule that has multiplication in it, it's going to be dilation. This is the only transformation that has multiplication in it. So this is the only transformation with multiplication. That is really important. Okay, so for a prime, b prime, and c prime, again, we're just going to multiply everything by 3. So negative 2, we're on a. Negative 2 times 3 is negative 6. Negative 3 times 3 is negative 9. Then for b, we actually... Okay, that's a little bit better. All right, so for b, we have negative 1 and negative 3. So, positive 1, positive 3. So we're going to multiply both of those by 3. So 1 times 3 is 3. 3 times 3 is 9. And then for c, 3 times 3 is 9. 1 times 3 is 3. Okay, so y'all see what we're doing there. All right, let me shrink that down just a bit. Okay. Now we're just going to graph. So a was at negative 6, negative 9. So 6 to the left, 9 down. And that again is a prime. B is 3, 9. So it's going to be 3 to the right, 9 up. And again, that is B prime. And then C prime is 9, positive 9, so 9 to the right, 3 up. And that is C prime. And I'm going to connect the dots. And there you have it. So as you can see, this was an enlargement because the shape got bigger. You could also look here and be like, oh, 3. We're multiplying by 3. Right? Remember we talked about this? 3 is greater than 1, so that means it would be an enlargement. Number 2, dilate the figure by a scale factor of 2 with the origin as the center of dilation. So the scale factor of 2 means that the new shape will be 2 times as large. So this will definitely be an enlargement. So the rule would look like this. So 2x, comma, 2y. That's what the rule would look like. And then you have a prime, b prime, c prime. So just multiply everything by 2. So for a, you just have negative 8. And 0 times 2, of course, is 2. For b, you would have negative 2, 4. For c, you would have negative 10, 8. So that's all you got to do for that. And then graph them. So negative 8 goes left 8. 0 means go up or down 0. That's a prime. B is negative 2, negative 4. So 2 to the left, down 4. I'm sorry, up 4. That's positive 4, excuse me. And that would be B prime. And then C prime is negative 10, positive 8. 10 to the left, up 8. And that is C prime. Connect the points. And the shape should look just like a bigger version of the original shape. It shouldn't look very different, just bigger. Okay, so again, that's how you do that. Number 3, dilate by a scale factor of 2/3. Now, 2/3 is less than 1, so this is going to be a reduction. So we call that a reduction. You see that right there. Okay, so a reduction means, that it's going to get smaller. In fact, it's going to be 2/3 as small. All right, so the rule for this one would look like this. And then you would just have 2/3 times x and 2/3. There's a lot going on up here. And then 2/3 times y. And that's what that rule would look like. And then we have a prime, b prime, c prime. Now, of course, if you're not good with fractions, you need to use your calculator. So let's try a first. So we have -9 and 9. Okay, so first we would have -9, and then we want to multiply that by 2/3. And then we get -6. And then, of course, if we did +9 times 2/3, we would get 6. So that was pretty easy. So that's -6 and 6. So again, we already knew that -9 is going to multiply to equal -6 by 2/3. So for b prime, that already starts with, -6. Now 2/3 of 3, if you're not sure what it is, just come over here. So 3 times 2/3 is just 2. So if I multiply that on my calculator, I get 2. So that'd be 2 right there. So you can use the calculator to do this, is what I'm saying. And then for C, -3 times 2/3 will be -2, of course. And then 6 times 2/3 would be 4 if you multiply that on your calculator. So now let's graph these points. We have -6, 6, and that would be A prime. We have -6, 2, that would be B prime. We have -2, 4, that would be C prime. Connect the dots. And there you go. So as you can see, this triangle is definitely smaller than the original. It's actually 2/3 the size of the original. Number 4, dilate by a scale factor of -1/4. Okay, so this one's a little weird because there's a negative sign, but the process is exactly the same. So that'll be -1/4 times the x values and -1/4 times the y values. So we have A prime, B prime, C prime, and we can use our calculator if you're not good with fractions or negatives. So let's start with A. We have a -8 and a -4, so let's go over here and do that. So -8 times -1/4 is going to give you 2, and then -4 times -1/4, oops, that was supposed to be a division, there we go, is going to give us 2. I'm sorry, I should give you 1. Didn't hit enter yet. There we go, we get 1. So we should have 2, 1. Oops. 2, 1. Those are the two numbers we got. All right, we already know that -4 times -1/4 is 1. 0 times anything is 0, so that was easy. This one, we have 4 and -8. We already know that -4 times -1/4 was 1. So since this is a +4, that'll be -1. And again, if you still need to use your calculator, just use the calculator. We already know that -8 times -1/4 is +2, so I'm just going to write the 2. Okay, now I'm going to graph +2, 1, and 1, 0, and -1, 2 for C prime. And let me move that out of the way. Down here, connect the dots. And there you go. As you can see, this triangle is considerably smaller. It looks the same shape, but it's just really small. And it flipped. It flipped because it's negative. When the dilation is negative, it's going to flip. If the dilation is positive, they'll both face the same direction like numbers 1, 2, and 3 did. Okay, so that's exactly how you do that. You should be good. Now, let's go down to number 7. Number 7 has two things happening. First thing we need to do, and I'm going to use colors to help us, is dilate by a scale factor of 2. And the second thing that we're going to need to do is reflect over this line. So this is what we call composite transformations, when you have more than one transformation occurring to the same shape, back to back. So let's do the first one first and the second one second. Always go in order. All right, so first we need to dilate by a scale factor of 2, which just means we need to multiply everything by 2. So A prime, B prime, C prime. We're just going to multiply everything by 2. So that'll be negative 8, 0, negative 6, 10, negative 2, 6. All I did was multiply all those numbers for A, B, and C by 2. Once you do that, you can graph it if you want. And in this case, I definitely think we should. So A prime was at negative 8, 0, which is right there. B prime is at negative 6, 10, which is there. C prime is at negative 2, 6, which is there. All right, I'm going to connect the points, and we'll take a look at the second transformation. Okay. So the second transformation says we need to reflect over x equals negative 1. So don't forget, when you see a variable equals a number as a line, so we have x, we're looking at the x-axis, we need to find negative 1, and then just draw a line through it. And that's how you graph that. Okay, so there's my line of reflection. Let me go ahead and highlight it. It's kind of hard to see. So we're just going to take this A prime, B prime, C prime, and reflect it across that line. So I'm going to use a different color again. I'm going to use blue. Okay, so again, I'm going to use blue to reflect. So C prime is just one space away, so we're going to go one space away in this direction. And that's going to be C double prime. We call it C double prime because it's the second transformation. Then B is 1, 2, 3, 4, 5. So we got to go this way. 1, 2, 3, 4, 5. So that's going to be B prime. And then A prime, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And that is A prime. I'm going to connect the points. Oh, I'm sorry. These are both double prime. Excuse me. All right. Connect the points to make a new triangle. And it should be the spitting image of the previous triangle, just bigger. Just bigger, just flipped. Sorry. All right, so there you go. Now I'm going to erase a few things. I'm going to erase the filler that I put on that triangle because that is not my final transformation, and I want to really highlight my final transformation so we know which one is the answer. So A double prime, B double prime, and C double prime. So A double prime was at 6, 0, because we had to go to the 6 right and up or down 0. B prime is at, looks like 4, 10. 4 to the right, 10 up, if you start from the origin. And C prime, if you start from the origin, it looks like you just had to go up 6. C double prime, excuse me. So that would be 0 and then 6. And there you have it, kiddos. Your first composite transformation. So the final answer would be here. That is your final answer. All right, number 8. Dilate the figure by a scale factor of 3 with the origin as the center of dilation. So that's the first one we're going to do. Okay. And the second one that we're going to do says rotate the figure 270 degrees. Rotate the figure 270 degrees. And it does not say clockwise or counterclockwise, and that was a mistake, sorry. So I'm going to put clockwise. Sorry about that. Okay, so let's do the dilation first. So scale factor of 3 means we have to multiply by 3. So A prime, B prime, C prime is going to be the exact same, just multiplying the original by 3. So that'll be negative 9, negative 9. Then that'll be negative 3, negative 6, and positive 6. So we just took all of these and multiplied them by 3. That's how I got these. All right, so I'm going to go ahead and graph it. So negative 9 would be 9 left, and then down 9. Then we would have negative 3, so left 3, down 3 for B prime, and then C prime was at negative 6, 6. 6 to the left, 6 up. And that's C prime. So I'm going to go ahead and connect the dots as usual. Okay, and so there you go. We stretched the figure. We have dilated the figure. The next thing that we need to do is rotate it 270 degrees. Do not forget the rule for rotation. 270 clockwise is going to be x comma y. Yes, you need to go back to your notes and look at this because I doubt you remember. And don't forget they switch places. So it's going to be negative yx. Yes, you need to go back and look at your notes. I don't expect you to remember that. All right, so now we have A double prime, B double prime, C double prime. All right, so don't forget, we have to switch the x and the y, and then the original y value will become the opposite sign. So then, let's zoom in so I can write a little bit better. So for A double prime, remember it was negative 9, negative 9. Even when you flip it, it'll be the same. However, don't forget, we need to make the original y value opposite. So now it's positive 9, negative 9. B prime, switch it. So negative 3, negative 3. And we have to make this one positive. And then for C prime, negative 6, 6. So sorry, that will be 6, negative 6. All I did was flip it, or switch places, and then change the sign of the original y. So now that positive 6 will be negative 6. And let's go ahead and graph it. 9, negative 9 goes 9 to the right, 9 down. So that was A double prime. Then we have 3, negative 3, so 3 to the right, 3 down for B double prime, and then C be negative 6 and negative 6. 6 left, 6 down, and that would be C prime. We'll connect the dots. And that's it. Alright, and so your final answer would be these, because that is the last transformation that was, wow, that was the last transformation that was listed. Alright, number 9. A rectangle is dilated. What is the scale factor if the image has a length of 20, but the pre-image has a length of 6 centimeters? So this, I know we don't like words, but let's just talk about how to do this. No, use blue. Okay, so when you're trying to figure out the scale factor, so for all these problems that had dilations before, you were given the scale factor. But when you're trying to figure out the scale factor, when you're trying to figure out the scale factor, so when you need to find the scale factor, which is just k, we use the constant k. This is what you need to do. You just do k equals new over old, or new over original, if you prefer. Okay, so let's read again. Has a length of 20, but the pre-image had a length, and don't forget, pre-image means old. So the old had a length of 6. So the old number was 6. The new number has to be 20 in that case. And that's pretty much your answer, but you need to simplify that fraction. So for those of you that still don't know how to simplify fractions, that's okay. Just use the calculator, type it in, hit enter, and then you get 10 over 3. So 10 over 3 is the scale factor. Number 10, a toy car is a replica of a real car. The car has 20-inch rims What are the sizes of the rims on the toy car if the car is reduced by a scale factor of 18? All right, so this one gives you the scale factor, and it says reduced. It says reduced. So that means that you're going to have to divide. If it tells you reduced, then that means you're going to have to divide. Or you can just set it up kind of how we set it up before. New over old. So new over old. And then we can just use proportional reasoning to figure that out. All right, so the car has 20-inch rims. So that would obviously, we're going to call that the new. We'll just say that the larger car is the new one. It doesn't really tell us. And the scale factor is 18. And it says it's being reduced. So the new one is 18 times as large as the old one. Or you could say that the toy would be the old, and then the real would be the new. We could just do that to make it easier. All right, so the real is 18 times bigger than the toy. And then the real car has 20-inch rims, and so I'm going to put that up here. And then we got to figure out this number right there. So this is just another way you can do scale factor by making a proportion. And yes, you can do cross product. So 20 times 1 is 20. 18 times x is just 18x. And then you can divide both sides by 18. And then we'll do 20 divided by 18, which is 10 over 9. So 10 over 9 equals x. If you want to change it to a decimal, don't forget, just do 10 with a decimal after it, divided by 9, and then it gives you 1.1. So you can also have it as 1.1 equals x. All right, number 11. What is the final location of 4, 5 if the following transformations are applied in this order? Reflect over y equals x. So here's the rule for that. And don't forget, use your notes if you cannot remember the rules, which most people can't. So use your notes. The second rule is dilated by a scale factor of 5. So that's going to be 5x, 5y. Just multiply both by 5. That's what that means. Dilated, reflected, and then rotated 180 counterclockwise. Direction doesn't matter because it's 180 degrees, but whatever floats your boat. All right, so then that one is going to be negative x, negative y. And there you go. So those are the 3 rules we're going to have to apply to this. And you know what? Let me go ahead and do this real quick. Okay, so let me do this so we can distinguish between all 3. Did not mean to do that, my bad. Okay, cool. So the first thing we want to do with 4, 5 is apply the reflection. So I'm going to just draw a little arrow. Okay, so we have to use this rule. So switch the 4 and the 5. So first is the reflection. Or maybe I should just write reflect. So once we reflect, it'll be 5, 4. Okay, so that's the first thing we need to do. And then we have to dilate. Okay, so the dilation says we have to multiply both of those by 5. So that's going to be 25, right? Because 5 times 5 is 25, and 20 because 4 times 5 is 20. And then lastly, we have the rotation. Okay, so for the rotation, we're just going to make both of those opposites. So it's going to be negative 25, negative 20. And since that was the last one, we are done. So the answer should be negative 25, negative 20. So this was the order of our transformations. All right, number 12. What is the final location of 12, 9 if the following transformations are applied in this order? All right, you should be able to do this one by yourselves. It's just like number 11, but with different transformations. All right, do not worry about numbers 13 through 24. So finish this, turn it in, you'll be good to go.